Okay, I'm going to show you, field techs, how to replace a FOSCAM IP camera power supply. This is the power supply. It's a 5 volts DC, 2000 milliamps, which is also 2 amps. The FOSCAM IP cameras, we've been finding a lot of the original power supplies will burn out over time, and then you're stuck with a camera that doesn't work and you have to find another replacement. So what I've got here is my replacement power supply. This one's actually a 5.25 volts. The reason I chose this one is because it's 2.4 amps as opposed to the 2 amps of the original one, because I figured that if the 2 amp one is burning up, then we probably need something with a slightly higher current rating. I don't think the additional 0.25 volts is going to be an issue. In fact, I'm probably going to be making the cord a little bit longer, so you'll get voltage drop, and even with your AC power coming in, your voltage is going to fluctuate anyways. The camera can probably tolerate it, no problems. But the issue is that the one that I bought, it's hard to find a replacement power supply that has the proper pin on the end. So the one I bought is actually a micro USB that you'd typically use to charge like a Samsung phone or something. So what I need to do is cut off the connector on the burnt out power supply and connect it, or replace the existing one onto the, we'll call it the USB power supply. So what we need to do is, first thing is we can cut off the USB power supply end. So I'll get this all opened up here. I'll grab my wire strippers and we'll just give it a snip like that. We don't need that anymore, that's garbage. And it looks like we got a red and a black in there. So let's just try and strip off this exterior jacket. Yeah, red and a black. I'll have to be a little bit careful stripping that because I just took a little bit of the insulation off the wires underneath. So maybe what I'll do here, just give it a bit of a more gentle snip, kind of bend it around, and then pull it off. There we go, nice and good. And then on this end, because I want to make my DC power cable longer, I'm actually, instead of just cutting off a little bit of the connector, I'm going to cut off pretty much right at the power supply itself. So this one's done, it's junk, and now we've got connector at the other end, and we'll just give that a bit of a strip. There we go. So on this cable you can see there's actually a red and a white. I'm assuming the white is probably the equivalent of the black on the other cable, which has a red and a black. But to remove any doubt, I'll grab my multimeter and I'll check the pinouts of the white and the red to see where it comes out on this end. So my guess, I believe if I look at the power supply, I'm not sure if you'll be able to see it on the camera, but if you look close enough, it actually has the pinout right here. And if you know how to read these, this is saying that the positive is actually the center of the pin, and the negative is the exterior of the pin. So when we look at this, we know that the negative needs to be this exterior housing, and then the positive is going to be the center housing. So we can check that pretty easily by grabbing a multimeter. Setting it to continuity check, and you always want to make sure it beeps. Oh, this one, hold on 1 second, go select. There we go. So now if I strip this white, hold that on there, and in theory this should beep. There we go. So we know that white is our negative. So that solves that mystery. So now what we want to do is we want to connect them together. And there's a few ways you can do this. One way you can do it is through a Moret connection, typical wire connector. I don't advise this. If you're in a jam, it's fine, you can do it. It's not a very good connection. It's a connection that's kind of meant to go inside a box, but what I'm talking about is if used a standard household wiring MRET. But in this case, this MRET is huge for the size of the wire, and what you're actually going to need, I've got a couple different sizes of MRETs here actually. They go down in size. So if you really wanted to use a MRET to do this, you would need an absolutely small size MRET, which is tiny. The opening inside, the little helical spring inside is small enough that it'll grab the wires when you try to twist them together, because let's say you try using a big one, it'll just twist and twist and twist on the end. You'll never grab it, you'll never get a good connection. With a small one, because it's suited for the smaller wires, you're going to get a better connection, and there you go. This is kind of a hokey pokey way of doing it. I wouldn't do it this way. It's not a lasting connection. It can be pulled apart, it's exposed, it looks ugly, and it looks shoddy. So another way you can do it is with good old-fashioned butt splices. So butt splices, you probably see them a lot in kind of more the electronics world. You would strip the wire, put it in one end, strip the other wire, put it in the other end, and then you crimp down, and then you kind of get a mechanical connection. They call it a butt splice because you're essentially inside that, you're butting the two ends of the wires together, and then you're crimping them so that they don't pull apart. It's a good connection too. I would probably maybe throw some heat shrink over top just to clean it up a bit. But in my instance, because talking to other technicians, there seems to be a history of these power supplies burning up, and I don't know if this power supply, who knows, might burn up also. I'm going to give myself the benefit of the doubt and make it easier for a future replacement on this, so that next time I have to replace a power supply, if it comes to it, I don't have to go through all this trouble again, cutting the cord and all this. So what I'm going to do is I'm going to use a spade terminal. And the way these ones work, these ones are insulated. The way it works is that on one end, you're going to have this kind of like flat blade, and then in the other end is going to be the socket. And then they go together like this, and that gives you your connection. So the nice part about this is that in the future, if you have to replace the power supply and need to keep the DC cord end, really all you need to do is pull them apart, replace the one end, put a couple of crimps on it, and then you can reattach to the new one. You don't have to discard the butt splices or anything like that. Now these ones aren't good because they're exposed, so that's no good with a DC power supply because you'll short out onto something like a conduit or whatever maybe you're strapping the wire to. So I have a version of them where they're actually insulated, so that when you put them together, they make the electrical connection inside, everything's insulated, and you don't have to worry about anything shorting out on something. So the way we're going to do this is, you have to think about this a little bit. So typically, I would kind of do things thinking of like a regular household receptacle. So if you think about a household receptacle, the socket of the receptacle is where the power is coming from. So instinctively, I would probably want to put the socket style connectors on the end that's the power supply, the source of the power, so that it kind of acts like a receptacle. And then on the cord end, which you're plugging into the receptacle, would be the kind of the blade style, kind of like a cord on, say, a lamp or something. But the reason I don't like that for this situation is because if I put two of these blades on the end of the DC power supply, in theory, they would be able to mate up with either polarity of the DC power supply. So you could actually connect it reverse polarity, and then you might end up burning out your camera if someone wasn't paying attention when they do it. So what I'm going to do is I'm going to alternate. I'm going to do one as a socket, one as a blade on this end, and then match it to the appropriate ends on the other side. And in that way, there's no way of reversing the polarity on them, because if you tried to do, say, positive to negative, it would be a socket to socket, and it's not going to work. So let me get my wire strippers here. Now I got to think about how much wire length I really want on this. I don't need a ton. Another thing I like to do when you have these kind of butt splice or these connections is offset them a little bit. So if I put them both on the end of the wire like this, what's going to end up happening is you kind of end up with this bulge, right? Because your wires are the same length, the bulge is both going to happen here. So if you think a little bit ahead, you can actually cut the one wire shorter and offset them a little bit so that you get a smoother kind of cable size between them. You could even throw some heat shrink on it if you wanted, just to make it a little bit cleaner. I'm not sure if I have any with me. Let me check here. No, it doesn't look like I have any heat shrink with me right now, but that's okay. We'll just do it the way we're planning here. So to start, I'm going to make my positive from the power supply. I'm going to strip it. The other thing you got to check is the wire gauge on this. It's a little bit, the wire gauge is a little bit small for the size of the terminal here. These terminals don't really come in anything smaller. Red is usually the smallest color. So what I'm going to do is I'm going to strip this a little bit longer than you'd expect. Right there, so I've got it stripped. And I'm going to fold it back on itself. And what this does is it gives it a little bit of more kind of girth when you put it into that connector for crimping. And then that way it's less likely to pull out kind of thing. So there you go. You see it, it's kind of folded back on itself. If you want to get really fancy, you could probably tin it with a soldering iron, but I don't think most of us in field operations has the time to sit down with a soldering iron and tin it. So here we go. We'll just kind of put that in there. And it's in there. Nice. So now I just need a crimping tool to crimp it on there. So here's my crimping tool. It's a Klein crimper. I don't know if you'll be able to read it, but it's actually got a non and an insulated crimping section. So you always want to make sure you use the proper one on each one. So the non-insulated, you can see it actually has kind of a dimple. And if you use that dimple on an insulated style, what's going to happen is that dimple will end up piercing through the insulation, exposing some of the metal underneath. So you can see that the insulated style kind of more like squeezes it from the outside without any kind of particular pressure point that's going to break through the insulation and expose it. So you always want to make sure you use the proper one. So I'll throw this on here and then just give it a squeeze. Take a look at it. Looks like it's good. Can't pull the wire out. It's nice and solid. So that's that end. So now to match the end on the other end, we used a socket on this end. That means I need to use a blade style on the other end. So what I was talking about before by offsetting them, so kind of what I want to do is actually cut this one a bit shorter and do the same thing, strip back kind of double the length of the exposed conductor, fold it back on itself, give it a pinch, and then you're ready to crimp on the blade connector. There we go. Blade connector's crimped on. It's good and solid, won't fall apart. Now these two can be mated together. It's insulated, it's nice, it's clean. You don't have to worry about any exposed metal, and it allows for easy replacement in the future. Now we can do the other end. So I've already got this white one stripped. I'm going to strip it back kind of double the length again and fold it back on itself. And on this one, we're going to be putting a socket style because you can see that the positive wire is a blade, so negative wire we're going to make socket. There we go. And then we can look at this one. I'm just going to kind of mock this up here. That's going to go together there. When this one's plugged in there, we're going to want that wire to be about there. So that means I want to, let's see, I want to cut it about there and strip it back. And fold it back again. put this one on. Now some guys might say, oh, you know, you shouldn't fold the wire back and it's making a bad connection and you should use the proper size terminals. Now, I don't think they actually make any terminals that are smaller for this. And my argument would be is that you're only looking at 2 amps at 5 volts. This isn't a really high current application, so you don't really have to worry about the connection burning up when you're folding it back and stuff like that. So I think folding it back on itself is probably just fine. I've seen tons of electricians do it, and I've never run into any issues with it. When I wouldn't do it would be if it was like 120 volts at 15 amps or something like that. Then I would make sure I'm using a better connection. So now you can see we've got the 2 ends. I've kind of offset them a little bit so that they're not just both bulking up at the same point. And it allows for a quick, easy replacement. If you had the heat shrink, you could probably get some heat shrink that would, you know, cover from here up to the terminal or something like that, just to clean it up a little bit. You could wrap it in electrical tape if you want. It's a little bit ugly. The tape's probably going to unpeel itself over time. It's going to be sticky. It's not a nice way of doing it. So let's connect these in all the way. And then what we'll do now is we're going to test our power output just to confirm that we've got the proper configuration. So I'm going to need AC power source. Got my extension cord here. Plug it in. Let me just kind of hook this up here so you can see it. Now, going to get our voltmeter again. And we're going to turn it on to volts DC. So on this application, we're expecting the center conductor to be positive and the outside housing to be negative. Now the center conductor, the hole on it is pretty small, so a little trick you can do sometimes is if you have a piece of wire, which I look like I have one, that fits in there, you can stick a piece of wire in there. I'll show you that up close. So what I've done here is, because I can't get the probe from my multimeter down inside to actually make contact with the positive point on it, you take a little piece of wire and you stick it down inside, and then that's extending the positive inside up outside, allowing you to get a multimeter probe on there. So now we apply the negative to the outside housing and we apply the positive to the center pin, and look at that, 5.42. So remember what I was saying, how the power supply is going to fluctuate. That's why I'm not worried about that 0.25 on the housing. Even if I had a 5 volt one, you're not going to get a true 5 volts on these things. These are just cheap power supplies. These aren't super sensitive electronics, and I'm pretty confident that the camera isn't going to have an issue with it. In fact, it's probably got an even wider input voltage tolerance on this thing. But at least we know we've got our polarity set up properly. Just so you'd see it if you had reverse polarity, you just note that on your multimeter you would probably show up with a negative symbol showing on your multimeter, which you can see there just ahead of the 0. So that's a negative polarity, and then this way you have your positive polarity, which is perfect. So we can turn that off, get that out of the way, unplug this. And there you go. You got a replacement power supply for your FOSCAM IP camera on your site, and you should have no troubles unless you got to replace it again. And if you do have to replace it again, all you need to do is just disconnect it, replace your power supply, and add a couple connectors on it, and you can leave this cable in place. Who knows? It's probably tie wrapped coming from your camera somewhere, and that's all you need to do. So thanks for watching.